Going on YouTube? Coach Carr here, bringing you another video. This one is on the area of 2D shapes. So we're going to go over the different formulas to find the area of these shapes. The success criteria is you'll be successful when you know the different formulas to find the area of 2D shapes and know what the letters represent. Now, the actual learning target is to identify and describe relationships among inscribed angles, radii, and chords. So we are looking now at page 1. On here we have the different formulas that we are going to use, and we have to know what each of them means. So for the area formula for a parallelogram, rectangle, square, it has the formula of A equals BH. So B stands for the base and H stands for the height. So when we look at it, if it were just a rectangle, base, height. Now the parallelogram, you notice, is kind of slanted. So the base would be the full length and the height you would actually have to find. So they made a little right triangle right here to find the actual height. So when we look at the first example problem, 16 would be my height. The full length here would be my base. So when I do it, A equals, now the base, the full base, 10 plus 8 is 18, times the height, which is 16. When I multiply those together, it would be 288. So you want to make sure you don't forget the units. Whenever you're doing area, it's going to be squared. So in this one, it's 288 feet squared. Okay, so the next one that we're looking at is the triangle. The formula for this is area equals base times height over 2. So again, B stands for base, H stands for height. So the height would go from the vertex straight down. So since this wasn't a right triangle, we had to create one. We could call this also an altitude. So when we do the example problem, the 3 would be the altitude, or as we will call it for this one, the height. So when we do the H, it will be 3. When we find the base, we're looking for that longest side. In this case, it's here. That's our base. So it goes base times height. So 5 times 3 all over 2. 5 times 3 is 15. Still over 2. And 15 divided by 2 is 7.5. And don't forget the units, so feet squared. Now, the next one we have is the area of a trapezoid. In this one, we have this formula here of area equals height, and in parentheses, base 1 plus base 2, all over 2. So H is the height, B1 is base 1, B2 is base 2. So when we do this one, the example, over here, 12 would be base 1. The bottom would be base 2. I know they're my bases because they are parallel to each other, and I know they're parallel because of these two filled in triangles on those lines. And they created a right triangle here to find the height. So the height here is 28 yards. So now if we actually go to do it, the height again was 28. The base, we have 12 plus 24 all over 2. So order of operations tells us we have to do the parentheses first. So 12 plus 24 is 36. So I have 28 times 36 all over 2. That gets me, I'm going to just put it over here, 28 times 36 is 1008. And remember, it is all over 2. 1008 divided by 2 is 504. So again, we can't forget our units. So in this one, it's yards squared. So the next one on here is for the rhombus or a kite. Now, when you have a rhombus or a kite, it has this area equals D1 times D2. So D1 is the diagonal number 1. D2 is diagonal 2. So when you're looking, let's say we look at this first one here. Diagonal 1 could be across here. So I'm going to make this my D1. Now, the full length is going to be 18 plus 10. So we would have 28. Now, D2 is a full length here. So I would add these together, 24 plus 24, and I would get 48. So now if I multiply them together to find the area, I would get the area equaling 1344, and don't forget your units, feet squared. So the area of this would be 1,344 feet squared. Now, the next one, the regular polygons, we're going to practice more later in the packet, but we still want to make sure we know what the formula is. And it says area equals A times P over 2. Now, A is the apothem. So, like they have here, it's even labeled there. An apothem is the height from the middle to the side. So, from the middle to the middle of this side here, that's an apothem. P stands for perimeter. And again, we'll have more practice with this later on in the packet. So now on the next page, page 2, the first one they have on there is the central angle. Now the central angle would be like the angle inside of a circle. If we have the full angle, this is like saying the area of a circle. So if I have the area of a circle, A equals pi r squared, where r equals the radius. Now, the other one, sector, which is what we're going to be doing a lot of practice of very shortly, is where you're taking just a part of a circle. So when I'm taking a part of a circle, I'm only having a certain part of the angle times pi r squared. So it's a lot like the formula we use for a circle over 360. Because the full angle, so if I went around in a circle, you're going 360 degrees. This symbol means an angle. So I'm just going to write it over here so there's a little bit more room. This symbol is an angle. So whatever angle you're saying, what portion you're talking about, that's what you'd put there. This is pi. So usually we'll represent it as 3.14. And then r is the radius. So much for watching. That's the end of this video. Now make sure that the exit slips for this one are going to be the problems that are going to be posted around my classroom. So make sure you are getting those done.